Welcome back everyone. Another quick little video in the tutorial series. Today we're going to have a look at field effect transistors and how they differ from a BJT. So let's get into it. Okay, so now let's take a look at a field effect transistor. So first of all, let's take a look at the symbol we'll see on schematic diagrams. Okay, so here we've shown a N-channel MOSFET, source, gate and drain up here. And how does that relate to our actual device over here? So this would be the source, here we would have the gate, and here we'd have the drain. So now let's take a look at it in detail. We've got a P-type material here with holes, and we've got two N-type materials inset into it. The source is heavily doped material. We've also got two additional things here. We've got an insulating material that is set on top of the P-type between the source and the drain, and on top of that we've got a contact for the gate. Now we can see we've got two PN junctions here, and they will operate the same as a normal PN junction, so we'll end up getting a depletion zone around this junction, and we'll also get a depletion zone around this junction here. So let's put a battery across this device. Now we've got two depletion zones here effectively, so we're not going to get any current flow through this device at this point in time. It's just going to remain off. So how do we actually turn it on? So if we apply a voltage between the source and the gate, what we'll find is once this voltage gets to a certain point, it will overcome this depletion zone and tend to repel these holes away from this insulated zone here, and we'll find that the heavily doped material with all the electrons in here will tend to start flowing through a channel that's formed to the drain. And the higher the voltage we put on this contact here, the bigger the field effect will be, and the more the holes will be repelled, and the larger this channel will be, so more current can flow. So effectively, with no voltage on the gate, the device is off because no current can flow through here. But as soon as we increase the voltage on that gate and we get above this depletion zone, the device starts to turn on and allow current to flow. And the higher the voltage, the more current. So where the BJT is a current amplifier, so a small base current will give a larger collector current, in this case it's a voltage controlled device. So the higher the voltage difference between the source and the gate, the larger the current flow between the source and the drain. So that's how a field effect transistor works. So hopefully that helps with your understanding of field effect transistors. If you like what I'm doing, then please like the videos and don't forget to subscribe, and please do tick the little chime indicator so that you'll be notified when I post something new. Okay, cheers for now.